In this video, we will talk about layers in neural network. To start with, we have three types of layers: input layers, hidden layers, and output layers. Input layers are the first layer in our system, and the output layer is the last layer in our system. Every other layer between input and output are called a hidden layer. You can have more than one hidden layers or zero hidden layer. Now let's dive into more details about each layer. Overall, input and output layers are based on certain rules, which we will talk about. But the hidden layers are based on experiments. You have to try different experiments to find the optimal number of hidden layers. But there are some guidelines which I will talk about at the end of the video. Let's get into details about input and output layers. I will talk about them by using two very simple, easy to understand examples. The first one is this dataset. This task is about predicting the price of a car. Here we have four independent variables: engine size, compression ratio, CT-MPG, and stroke. And we have one dependent variable, which is price. In this case, we will have four input columns and one output column. If you want to build a neural network for this data, you will need four neurons in the input layer and one neuron in the output layer, like in this example. We have engine size, compression ratio, CT-MPG, and stroke. This data will go through the hidden layers, and then at the output you need only one neuron, which represents price. The price will be the answer of the neural network. Let's switch to the second example. Second example is about MNIST dataset. Here we have 28 by 28 pixels images of different handwritten digits. Overall, the image has 784 pixels. If you build a fully connected neural network, then every pixel will be fed into the network. That's why you will need a separate neuron in the input layer for every pixel. In our case, we will have 784 neurons in the input layer, every neuron for every pixel. Keep in mind that our task here is to find the correct digit. As you know, we have 10 different digits, so we need 10 neurons at the output layer. Every neuron will have the probability of the image belonging to a certain class. For example, if you have 0.8 at 7th neuron, then it means that that image belongs to the 7th class by that probability. To sum up, for the input and output layers, you need to look at the dataset and the problem. According to your dataset, you will set your input layer and the neurons in that layer. And if it's a regression problem, for example, you will need only one neuron at the output layer. If it's a classification problem, you will need neurons according to the number of classes in your problem. For example, here we have 10 different classes, that's why we will need 10 neurons in our output layer. You can also check my Medium blog about the topic. The link will be in the description for both members and non-members. Now let's go to hidden layer and talk about it. How many layers we need and how to determine this. First of all, we have some guidelines. Starting with first one, start simple. When you build a neural network, always start simple, with one hidden layer and test the results. If it's successful, then you're okay with your model. If it's not successful, it doesn't generalize successfully, then you need to increase the number of hidden layers in your model. The second rule is to consider problem and dataset complexity. Again, if your data is more complex, for example, it's a bigger image or it's a video, or it has many independent variables, then you will need more hidden layers in order to capture those complex patterns. The third guideline is that to check existing solutions to similar problems. For example, you might have a certain architecture which works very well for your problem, and it has been checked by other people already. Then you can start with that architecture and test your dataset on that architecture. If it works well, then you will be fine. If it still has problems, then you can continue by changing that architecture. The next guideline here will be a little bit different. It's if overfitting, try regularization. For example, If you have increased number of hidden layers, then your model starts to overfit to the train set and doesn't perform equal on the test set, then you might think that you need to decrease number of hidden layers. But you can keep the number of hidden layers same and try regularization techniques like dropout on your model. In this way, you can keep the model complexity and also solve overfitting problem. The final tip is that you need to try many experiments to find the optimal answer. There is no certain rules again in hidden layers. You need to try all of them and check which one works very well for your problem. Don't forget to check other videos and to like and subscribe for more videos like this in the future. Thank you very much. See you later.